Okay, welcome everyone to this continuation of AI for the working mathematician in 2025. Yeah, and really, it's really evolving so fast. So yesterday, I'm recording this to just be precise here. I'm recording this October the 23rd of 2025, and yesterday we were using the standard AIs that you can all use for free online to get some information about the semantic group. Semantic group, I've studied semantic groups for a long time, and I feel like I should know most about it. And we still found we had a problem, and we just asked the question, and we still found a formula that I haven't seen before. And I was like really surprised. So it's one of these formulas that appear somewhere in the literature, but not in the standard literature, right? So that's something AI is really good in finding, and so that helps a lot. So maybe one of the advantages of using AI is actually, so like 40 years ago, if you weren't a student at the right place, there's certain knowledge you never had access to because of kind of it was not in the literature. People were kind of just, it was one of these folk theorems that just went from advisor to advisor or something like this. This is still going on, don't get me wrong, that's still the case, but not as prominent anymore as like 50, 40 years ago ish. The first revolution was like you could search online for results, that was really good. And now using AI to search for results is actually, in mathematics, is actually pretty useful. And the reason why this works so well is that it's a large language model, right? So, so it has learned a lot, it has read a lot, whatever that means, and yeah, that's why it is so good. So again, it found something that I should have been aware of, but I wasn't. And as soon as it pointed it out that there is a formula of a certain type, it's actually easy to prove the formula. It's kind of interesting. It's literally like, so say there is something that is completely obvious that you really should try, but nobody points it out to you, so you don't try it. And now it pointed it out, and then I tried it, and it's absolutely amazing. That's really good that it works this way. And something that works very similar, and I was going to discuss today, is coding. So coding essentially, well, why can it code so well? Because it has read a lot of examples of coding, right? There's a lot of online resources on how to code. Usually it's really good with the more prominent a coding language is, programming language is, the better it is with it, right? Like Python has a huge documentary, the documentation, so it's really good with Python or JavaScript or Java or something like that. And I still show you that it's reasonably good with smaller coding languages. I will show you a Magma example as we go along. So Magma is clearly not one of the big like Python languages. It's a very tiny computer algebra system type that can do a lot of algebra type calculations. Right. So the strategy is always, in this case, that you should turn a math idea, maybe you have some idea, into some code. Maybe you want to double check something, maybe you have conjecture, maybe you need some examples, something like that, right? So you can use AI to generate code. And the way you do this is, it's kind of really good in the sense that you don't need to know a lot about coding. AI will do most of it. So you can explain the problem to it. I will do that live. Whether it works live, we'll see, but I will try to do it live in a second. So you literally explain the problem to it, and it will figure out how to do it anyway. It's not going to do really big things for you, so you need to do it kind of step by step, kind of snippet by snippet, but still pretty good. So conjecture, whatever, that's really useful in mathematics, and was probably one of the first usages of everyday AI in research in general, I think. So coding works really well. So, but again, not in the big picture type thing, but more like in little blocks. Yeah. So you still need to guide it. You still need to know what you want to do. Can't do that for you, not at the moment at least. And yeah, so still under human control, right? So let's see. Actually, let me maybe zoom in a little bit. So there's actually research on this. So let's have a look here. It's kind of really good. We have a look at the. Let's have a look at the paper actually, so that you that you know what I'm talking about. So I'm using here the paper which is called The Effects of Generative AI on High-Skilled Work. Yeah, high-skilled work, coding is high-skilled work. It's, I think, Microsoft Research, so let's have a look here. It's all the same, probably. And they have a lot of, I guess, preprint. They have a lot of, complicated. Download this paper. They have a lot of nice examples. And so I stole some of them here. And essentially, you can have a look at it, right? It's freely available. They have a lot of nice graphs. If we scroll down somewhere, yeah, here, some nice graphs. Blah, 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 some comparison. It's, of course, a toy model that they used, but research usually is just all about mostly toy models. And before we zoom in here, let me just pull up, actually, the idea here. Controlled experiments, so people have done that, right? People have studied how useful is AI with coding, for example, or as the name suggests, high-skilled work, whatever high-skilled work is. And literally the quote I make from this paper is, our analysis reveals quite a large increase in completed tasks about developers using AI tools. And they have some more information on the study and whatever. It's pretty good. And roughly what they show, and that's kind of nice. So here, essentially, pull requests, commits, build success rate, and they used AI, and here you have an increase. And kind of an interesting feature here is, and I think this is kind of very strange and very unique, because in my head, at least, it's the opposite way, that the more you know, the better is AI for you. But here, as you can see, I mean, they just distinguish it by blue, which is short tenure, versus red, which is long tenure. Let's just say these are the less skilled ones. Let's say that works this way. And these are the more skilled ones. And you can see in all of these that the less you're skilled, the more you will profit from using AI in coding. And here, some kind of the same junior level, senior level. The more you're skilled, the more you will. The less you're skilled, the more you will profit from AI in coding. But in general, overall, you will profit from AI in coding, except for some outliers. But usually, that's what you should think. Low pre-productivity, same kind of type of effect, right? It's kind of a very interesting study. Kind of nice to read. And kind of contrary to what I usually say, as I said, usually I would say the better you are already, the more AI can help you. Here in coding, apparently, at least this study suggests, that's the other way around. Which is great for mathematicians, because most mathematicians are not good at coding. Like most people, I guess, are not good at coding. So yeah, you can actually really use that in your research. It's really useful, or in your studies or whatever. You don't need to know a lot of coding to profit from AI in the AI effects on your coding skills. So why is this actually so good? Why are LLMs so good at it? Well, most programs are actually the same, right? Most programs use the same patterns. Why is AI so good in solving math problems, small math problems? Because most math problems are actually very similar. So there are very few things we actually know well. Yeah? Math is about rigorous proving whatever, and there are not many things you can prove. So most proofs follow the same outline. That's why AI is so good in outlining proofs. Similarly, most code blocks follow the same pattern, and of course, it has seen millions of these. Millions is probably, I have no idea how many. I just had millions here, probably even more. They've seen a lot of it. Yeah, that's what the LLMs are really good at. They have seen a lot of examples, and they kind of will repeat it very well, right? So online resources, by the way, I found this funny study here. Stack Overflow apparently is a big part. Blogs, so on coding or whatever, right? Online books, not so important. But also AI itself, kind of interesting. So this is like where it gets its coding experience literally from. Yeah, it's really good. So for coding, it's really good. Somehow all the blocks are roughly the same. And I described the problem in plain language, And because of coding is almost very similar, the model just gets the syntax right? The annoying part of coding is to get the syntax right. Maybe you missed the whatever, a semicolon somewhere and the code doesn't run. It should be really good with this, right? In particular, you get an error message, you feed it back in the error message, and it actually works really well. So let me give you one example from my own research, and then I do try a live example from research. It will be a toy example because I don't want to blow up the video, but hopefully it will work nice. So essentially what I did is, and this was magma, in case you don't know what magma is. Magma is, let me pull it up, I will do it anyway. Here you go, magma, the computer algebra system from the University of Sydney. Very specific, but its documentation exists. It does things like this. It can work with fields, modules, finite groups, algebraic geometry, arithmetic geometry, very math-like, lead theory, representation theory, whatever. Here, representation theory, creation, representations of some meta groups, whatever, blah, single values, blah, something like that. So it's like really built for mathematics. The documentation here is pretty good, but there is definitely not as much documentation for magma as there is for Python. So whatever I'm going to show you for magma, or whatever your favorite language is, probably when you program it in Python or R or Rust or Java or whatever you like, it probably will do even better, because this is a really small programming language here that we're talking about. Okay, but back to this. So I literally just feed it up. You don't need to know what it's doing. It's very fancy, actually. Very complicated stuff that I tried. So I feed it something and blah, 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 it generates code. So now I fed it some code and I wanted it. I attached magma code, the final calculation, blah, should only be started if something happens. And then it did this, and then I readjusted it, and I wanted something else, and it was a long back and forth that I'm going to show you as well. But that's literally what you do. You just ask it. You don't need to know a lot about it, and it will do very well for you. So let us try a live toy example to see how it goes. But before I show you here when I did that, again, I'm using ChatGPT. You can use any of the AIs. They roughly will be the same. I'm just biased. I just use it. I probably shouldn't because it's not open source. But there's this big discussion whether actually, if you make something not open source, someone has an financial interest in it, then it actually will be better. Whatever, this is not a video about the philosophy, how you should think about something. It's more like what works, so you can use any AI. Anyway, so I attached the file, blah, 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 blah. I wanted something, it gave me code. And no, that doesn't work, somewhere it doesn't work. So we changed it then, I changed something, and blah, 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 I changed something, and then, sorry, it works, but I didn't want that, the procedure below, blah, 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 blah. I didn't want that, and we can change that, and so it's a back and forth, right? So I'm kind of guiding it, but it does all the main programming, and this is not an easy programming thing to do here, as you can see. Okay, let's try a live example. I hope this works now. I tried this several times, and it always got confused between gap and magma. I don't know why. Maybe that's just a bug. Usually it works really well. So in magma, I want to compute the character tables of all the small groups, say up to order 10, and check how many entries are 0. Can you generate code for me? Probably you need to use, which produces the irreducible characters. I tried this before, and you always confuse gap code and magma code. So hopefully you will now not confuse gap code and magma code. So let's see. I need to generate magma code that properly handles character tables. Character table. I think it's rows, maybe class functions. Irreducible characters. No, that doesn't work. Number of irreducible characters. That doesn't work. So I'm worried it might not be correct for magma. The user warning about avoiding confusion gap in mind. So I'll stick with character table for now. That's right. So character table I'd use. So let's see how it actually does it. So yeah. So with smaller languages, it really has the problem of confusing syntax from bigger languages, but it still should somewhat work. I'm considering blah 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 blah. I'm thinking of using. You should use character table. Yes, please use character table. But okay, done. Let's see. You're right. Magma in Magma, you want to use character table, not the gap style irreducible characters. Yes, exactly. Character table, that looks fine. And see character table IJ, right? Yeah, exactly, that looks fine. So let's see whether this actually works. And as I said, I tried it before and it confused it with gap code. That happens from time to time. And there you go. It works actually really well. So this took me quite a while. I cut out a lot of things. So it was about 10 minutes. That's how coding with AI usually works. With real programming language, Magma is a programming language. With more prominent programming languages, it will be much better. But even it can do even smaller ones. It just sometimes gets confused, and you just need to tell it a little bit what to do sometimes. But anyway, sometimes I was just really lucky and it spit out perfect code from the beginning, so it's a little bit of a gamble. But I really would recommend try to use it. Also, my life experience here wasn't all that good, although I will cut it in a nice way. So essentially, right, so let's have a look at the prompt again that I used. Essentially, I warned it because in the attempt I had before, I used it one time before, it essentially gave me gap code instead of Magma code. So it should be able to do it, and it was able to do it. So sometimes you need to correct a little bit by hand. Yeah, doing something live is always a bit annoying, but in general, it's like really good. No? I show failures. There you go. I show failures. I needed to do it twice in order to get the correct thing, but that's just what it is. So summary, really. So usually that's what I want. Say what you want. I want characters of finite groups up to all or whatever. Get a draft, run it, potentially fix it. I wanted something that works out live very well. That didn't work, so I needed to do it. I need to fix it, and I repeat. But this is essentially how it works, and it gives you quick evidence for a conjecture, right? So maybe one of our conjectures would have been something like, let's have a look at the results. Density 0, density 0, density 0, density 0, density 0, that is density 1/9. So maybe our conjecture would have been the density is 0, but no, the density is not 0, there's a 1/9, whatever. 1/58, but the density seems to be pretty small. Grand density 9 over, maybe your conjecture is that the density over all groups goes to 0 or something like that. You could run it a bit further. So here it generates a character table, whatever. So for n is, well, maybe we run it to 20, see what happens. Submit. The density is still pretty low, so maybe let's run it to, I don't know, 32 or something. 32 is a good number usually for groups, and it's essentially instant. It's pretty good. Density is, density rose. So yeah, so you can generate your own conjectures, you can try to test them. This is obviously just a toy example. And yeah, it's usually really good. Anyway, I hope you enjoyed this video, and I also hope to see you next time.